Hello everyone, this is Mashael AlKadi, a PhD student at the University of Edinburgh. In this video, we will present our paper titled Show Me My Users, a dashboard visualizing user interaction logs by myself, Jinrui Wang, and Benjamin Bach. This paper describes the design of a dashboard to monitor users of visualization tools in the wild. The dashboard has 3 pages. Firstly, the overview page that allows monitoring the tool's overall usage. Secondly, the visualizations page allows monitoring the visualization's usage and features. Thirdly, the user's page to study individual exploration sessions. Various tools are being developed to facilitate network creation and visualization. Those tools differ in what they offer, including types of network visualizations such as node link diagrams and timelines, exploration and analysis features, and their level of interactivity. Different studies investigated the usage of such tools using mini questionnaires, videos, interviews, task-based evaluations, loggings, and others. But most of those studies were conducted in controlled settings. So how can we have a live reflection of the tool's usage in the wild? Meaning that we can understand users' needs and usage coming from different backgrounds. To do so, we have selected the Visitorian, which is an open source network visualization tool that offers 4 types of interactive network visualizations, which are node link diagrams, adjacency matrix, timeline, and network overmap, in addition to a coordinated view. The Visitorian offers an interactive exploration experience, such as filtering by time, link type, node type, as well as tweaking visual representations, bookmarking, sorting algorithms, and others. Through logging, we were able to enhance and improve the tool's usability as we go to offer a better experience for remote settings. We logged 2,298 users over 28 months. Thus, in this study, we decided to use logs to offer a live reflection of how users use the tool. Not only that, but to combine our analysis with understanding the impact of educational efforts, such as workshops and courses, and use of supportive material such as videos and tutorials. So we started by forming 2 research questions. The first one is, what information to capture about users using the tool? Our collected logs were classified into 7 categories. Each log event is described by its purpose, when, and where it occurred. We use this classification in our analysis to understand more about the visualizations and features usage by users. The categories are as following. Data management logs category, such as the user creating a network, choosing a link table or node table. Visualization and interaction category, such as creating a visualization of a specific type, let's say a node link, and interacting with it. Help and support material category, such as watching a video or visiting a tutorial. Interest and communication category, such as contacting the development team. Reporting issues log, which helps in troubleshooting purposes. Bookmarking tool category, such as capturing a network state and annotating it. And the last one is other logs category are related to providing feedback, navigating between pages, and capturing users' activity state. So we started with logs categories. Then we came to our second question, how can we present these data to an analyst to support decision making? Inspired by dashboards in education, learning analytics can help us understand more about our users and the learning process. But live monitoring in visualization tools is a bit tricky. Unlike education, there are no explicit wrong and correct users' choices that we can benchmark to. So, how can we carry the analysis a bit further to offer better insights about actual needs of each user? Noting that not all tool users share the same needs, some are a bit more experienced and some are newcomers. Thus, we refer to the 4 user types we identified in the network visualization tools that we found in our previous study, which are Demo users are users who worked with demo datasets and examples only. Data strugglers, which are users who were not able to create even a single network. Single session explorers are users who managed to create and visualize the network and use the tool for a single session only. And lastly, multi-session explorers are users who manage to visualize networks and explore them through multiple sessions. To know more about user types, please refer to our paper from Viz 2022 titled by Understanding Barriers to Network Exploration with Visualization, a report from the trenches by AlKadi et al. So we added user types to the pipeline and we used those two classifications as an input to the analysis process. In the analysis process, we started by determining the metrics we needed to understand the tool, the visualizations, and the user. This took us a step ahead to think about how to make those metrics more concise and let us think about the KPIs and visualization tools. So what are the KPIs in data visualizations? We listed metrics and refined them through multiple cycles for each aspect. This included metrics for the tool, the visualizations, and the users. We then grouped those KPIs and created the pages, which are overview page, visualizations page, and user page. This resulted in 3 different pages as the pipeline shows. Firstly, the overview page represents the general activities within the Visitorian, including user statistics describing overall statistics, such as the 4 user types, temporal trends. For example, the timeline witnessed a big increase for multi-session Explorer visits over the exploration course in summer 2022. And key features usage. For example, in help resources, demo users and data strugglers rely on videos more than explorers. Secondly, the visualization page compares users and interaction features across the visualizations and views. Node link diagram, adjacency matrix, map, timeline, and coordinated view. For example, we can observe that the default node link diagram is most popular among users while people spend more time exploring coordinated views, and this was expected as it offers 2 visualizations to compare and interpret through them. And lastly, the users page visualizes timelines of users' exploration sessions with the ability to filter them by their user type, event category, and visualization view. By filtering data strugglers as an example, the timeline shows that they failed to reach any visual exploration after attempts in creating a network. As you can see here, multiple blue events, which none of them ends with an orange one, which is the visualization event, meaning that those users were not able to create even a single network. Another example is for multi-session explorers. We examine sessions of 2 different users. From the first glance, we can see that the second user on the right was more engaged with the exploration process due to the longer session duration. However, a common exploration behavior is shared of initiating the exploration process with node link diagrams, branching to others such as adjacency matrix. And the third example shows how different forms of a specific exploration interest can be captured. For example, interest in temporal exploration is captured by different means, as in the first user by exploring timeline visualization, whereas in the second one by using the time slider. Thus, we can find that analytical dashboards and data visualization can enable us to understand user trends, understand individual exploration, and provide insights to improve tool features. So those have implications on casual monitoring, and we mean by that the constant, exhaustive, and up-to-date display of interaction log data, KPIs for interactive visualization applications and how to define them, and lastly, supporting visual exploration through improving tools design and the support of material as well as educational material. In this paper, we presented a dashboard design and analysis pipeline for visualizing user interactions with an interactive visualization tool. Our observations showed how monitoring users over a period of time can inform decisions for interventions and further analysis. Thank you for listening.